Hey Kiwi. What do you think about all the sound wave energy we are learning about in science class this week?
Actually, it is all pretty interesting. I never really looked at sound in a scientific way, but the information really makes sense. Sound vibrates through a medium, and just like light, it transfers energy and not the medium, which could be a solid, liquid, or gas. It is a longitudinal wave that transfers sound waves through a series of compressions and rarefactions in a parallel direction.
Sound waves also behave similar to light waves in that they can be reflected in the form of echoes, diffracted through openings or around barriers, and even absorbed. Which I can appreciate absorbed sounds, that way I don't always have to hear everything my sister is saying to her friends when she talks on the phone all day closed up in her room.
Good points. Sound also travels at different speeds according to the type of medium, density, temperature, and elasticity of the medium. The more tightly packed the particles are, the easier it is for sound energy to travel from one particle to the next. The faster the particles move due to temperature means that the particles allow sound energy to travel faster between particles. Now, elasticity is a trickier topic to understand.
Well, elasticity of an object just means that you are looking at the degree to which an object can maintain its normal form after a force is applied. This means that the higher the elasticity of an object, or the higher its ability to maintain its original shape, implies that sound travels faster through the object.
Okay, that makes a lot of sense. We can't forget about pitch and frequency. Frequency determines the number of waves that pass in a second. The higher the frequency of waves means that the pitch will be high, like my mother screaming when she sees a mouse run over her foot. A lower frequency means that the pitch will be lower, so a low C to the right of middle C on the piano has a lower frequency than middle C. This shows that there is a direct relationship between pitch and frequency.
I should add that there is a relationship between the wavelength of the wave and wave frequency. This is an inverse relationship. This means that the higher the frequency, the shorter the wavelength, and the lower the frequency, the longer the wavelength.
That's cool. So far I think we have learned the main ideas behind sound wave energy. I heard that we will be talking about everyday sound experiences like the Doppler effect in our next few classes. It will be interesting to see the science behind the sounds produced from moving objects.
I guess I will see you in class 5th period.
Okay, see you then.